Hi, everyone. Just wanted to take a minute to talk a little bit about inequalities involving one triangle. Um, this is kind of the first step in our discussions on inequalities involving triangles. And the first theorem that we have encountered in regards to this is something called the exterior angle inequality theorem. Now, that theorem just states that if I have an exterior angle of a triangle, it is bigger than both of the two remote interior, which would be in this case A and B. Now, the reason behind this really just comes from the fact that we know from the exterior angle theorem that the measure of angle 1 is equal to the measure of angle A plus the measure of angle B, right? That just comes from the exterior angle theorem, um, which you could do out if, because you know that all triangles add up to 180, and then this is a straight line, so that adds to 180, so substitution, bam. Anyway, so you know that this is true. So it then stands to reason that if the measure of angle 1 is equal to the measure of angle A plus the measure of angle B, we know it's an angle, so both these must be positive. It's very obvious then that the measure of angle 1 is bigger than the measure of angle A, and that the measure of angle 1 is bigger than the measure of angle B, right? That just follows from the definition of what it means to be an inequality. If I tell you that, the measure of angle 1 is bigger than something, measure of angle A, by the definition of inequality, I can add something to the measure of angle A to get the measure of angle 1. In this case, it's the measure of angle B. So that just really follows directly from what it means to be an inequality. All right, so let's kind of see how this works out in an example. So if I told you, here's your angle, which angles would 1 be bigger than? So let's just kind of look. What angles is 1 going to be bigger than? Well, or greater than, I should say. Well, by the triangle the exterior angle inequality theorem, we know that this is an exterior angle, so it's bigger than the two remote interior angles. The only thing that we need to be careful of is there's a lot of triangles involved in this picture, right? So we have this triangle, and if I use that triangle, it's bigger than what? Measure of angle 3, measure of angle 4. Okay, that's fine. But let's pretend I didn't use that triangle. What if I used this triangle? That's still a triangle. Well, now I can say that the measure of angle 1 is bigger than the measure of angle 5. I can't quite say exactly what this is. We didn't get a number on the inside there, so I'm not going to write anything. All right. Well, now what? I could still also use the whole triangle. So we know that the measure of angle 1 then, by, again, the exterior angle inequality theorem, well, it's going to be bigger than the measure of angle 7 and 9. Right? I don't know how these all relate to each other. I don't know if 3 is bigger than 4, or 4 is bigger than 5, or 5 is bigger than 7. I have no idea. All I know is that 1 is bigger than all of these things. 8, sorry, not 9. Right? So I don't know a whole lot of what's happening in this triangle, but I can tell you these 5 pieces of information just based off of that. I could kind of work similarly with this side as well, if I so desired. But that's how this all plays out with the exterior angle inequality theorem. Now, the other thing, and the thing that we probably care a little bit more about with this particular sequence of events, is the angle-side relationships, which just state that if we have the sides of a triangle that are not congruent, there is a relationship between the angles and the sides. And it says the following. If one side of a triangle is longer than another side, then the angle opposite the longer side has a greater measure than the angle opposite the shorter side. All right, so what's that saying? So that's saying if AC is like 12 and AB is 8, the angle opposite it right? So in this case, the angle opposite of AB would be C. So really the one that's not used in making the segment. The angle opposite of AC would be B, right? AC is bigger than AB. So that would essentially mean that the measure of angle B is bigger than the measure of angle C. Okay, and it works in reverse as well. So if C was bigger, the measure of angle C was bigger than the measure of angle B, then that would mean that this side would be bigger than this side. Okay, so that is all that the triangle side relationships are stating. All right, so if we know an angle, we can kind of know relatively the size of the side. All right, we know the side, we can kind of sort of know the angle. All right, so let's actually look at what we have going on here. So here we have a bunch of different triangles, and based on this information, we're not really given any angles. We're given a bunch of sides. So if I were to just look at a triangle RQW, right? Well, what do I know here? I know that this is the shortest side, so that means the measure of angle Q is going to be the smallest angle, right? The one opposite it. W, that's opposite the largest side, so that's going to be the biggest one, and R is going to be in the middle, okay? Similarly, I could do kind of another reasoning over here with this triangle. Well, what do I know about RTS? All right, if I'm just looking, by the way, at triangle, technically speaking, by the way, I should have said QRW, since R is shared by quite a number of triangles. And that would be QWR. But similarly, I could also look at triangle TSR. Well, what's going to be the shortest side? Well, ST is, so that would mean measure of angle TRS is going to be the smallest. 35 is in the middle, so RT is used, so the measure of angle S there. And then this one, opposite of the T, going to be the largest. So the hardest thing of kind of remembering is if you're looking at an angle, you go across to the opposite side. And if you have a side, you go across to the opposite angle. All right, that's going to be the hardest part to try and remember. The rest of it is relatively straightforward, but I think sometimes people get lost in which angle they're looking at. So ultimately, that is everything that we need to know in regards to the angle-side relationships and the triangle inequality. I'm sorry, the inequalities in one triangle. Let me know if you have any questions, and have a great day.